This video will give examples of careers in precious metals using chemistry, both inorganic and organic, chemical engineering, metallurgical engineering, and others. Hydrometallurgy Part 1 introduced the various leaching processes as the first step in precious metals extraction. Part 2 presented the means of concentrating the solutions. After solution concentration and purification, the next step is to turn the precious metal compounds back to metallic form. Metal recovery will require a number of steps depending on the precious metals involved and depending on other base metals that may be carried along in the process. Each of these processes selectively reverses the chemistry to recover the dissolved precious metals either as compounds, alloys, or metals. In simple terms, the precious metals were put into solution by stripping electrons to create precious metal ions, which were dissolved into solutions. The processes to turn these ions back into metallic form each transfer electrons back to complete the transformation. Cementation is the most straightforward process used. Cementation is a precipitation process in which metal ions are reduced to their metallic form by taking the electrons back from other metals. Metals can be lined up in the order in which they will take electrons from each other. This order is called the galvanic series or electropotential series and is important in the fields of chemical precipitation, electrolysis, as well as corrosion. The more noble metals will take electrons from less noble metals in reactions. The sacrificial metals are mixed into the solution in fine powder form to increase surface area and reaction rates. An example of this galvanic reduction is metallic gold being created from a solution of gold chloride. Either copper or zinc powder can be used to do this. The precipitated fine gold is referred to as gold sponge. Dissolved silver is precipitated or cemented out of solution in a concentrated form with zinc dust, for example. It is then filtered, dried, and melted into doré bars for further refining. Doré bars are semi-pure alloys of gold and silver, since small amounts of other metals also precipitate out during the silver cementation process. Metal ions in aqueous solutions are also used to reduce precious metals to their metallic state. Here are examples using tin in the +2 state, which will give up 2 electrons to convert to the +4 ionic state. The precious metal ions receive these electrons and cement out as solids. An additional method for transferring electrons is through chemical reactions using chemical compounds. A number of chemical compounds can be used to precipitate gold and other precious metals from solution, including sulfur dioxide gas, alkaline hydrogen peroxide, ferrous sulfate, or oxalic acid. Sulfur dioxide gas is a widely used reactant which is injected and circulated into the solution. Advanced techniques include closed systems for gas containment and recirculation. Sulfur dioxide gas adds no other metals into the refining process, so is ideal for producing high purity precious metal powder. In summary, this refining process diagram shows examples of the many chemical reactions using precipitation to separate, concentrate, and refine precious metals. Electrolysis is the other general method used to extract precious metals from solution. It utilizes direct electric current through the solution to drive the chemical reactions. This technology will be presented in our next video. The International Precious Metals Institute promotes the education and appreciation of precious metals technology and business. IPMI is an international association of companies committed to providing technical resources and educational materials, including a series of videos presenting examples of precious metal applications and a variety of interesting and rewarding career opportunities.